Okay, we're going to do a little supplement here in Excel for creating confidence intervals. Remember, we've created those confidence intervals where we have that point estimate from our sample. And that's just the sample mean. What we're trying to estimate with that is the population mean. So we take that sample and we get the sample mean, and we can say that, you know, we've got reason to believe that the population mean should be close to that, but it's obviously not going to be exactly that. So what we do is we expand that to make an interval. It's a confidence interval. That confidence interval is based off of finding a margin of error. And so the interval itself is the point estimate minus that margin of error, I'm just going to call it ME for now, to that point estimate plus that margin of error. So the key is calculating that margin of error. And that margin of error is our critical value of Z or T, depending on which distribution we're using, times our standard error of the means. So SE, the standard error. Standard error or standard deviation of the sample means, whichever terms you're using for it. So we want to look at here quick is we want to look at using Excel to find those confidence intervals. Now the Ti83 calculator, Ti84 calculator we saw can spit that out rather quickly. Let's put a situation down here. Let's say we've got a population standard deviation of 14, a sample of 47 items gives a sample mean of 59. Construct the 95% confidence interval of the population mean. So as we saw, the calculator can do this rather quickly. We're going to go to Stat, Tests. This is a Z interval, so that's option 7. We're going inputting it with the stats. 14 is the population standard deviation. X bar is the sample mean, which is 59. Sample size was 47. And our confidence level is 95. So we're going to calculate. And the calculator splits out this range. Unfortunately, Excel does not do a range. What Excel does is it finds the margin of error. So in Excel, we're going to use the equals confidence command. We're going to use the equals confidence dot norm. And what it asks for is not the confidence level, but alpha. For a 95% confidence test, alpha is 0.05. Remember, alpha equals 1 minus the confidence. So 95% confidence would be 0.95. So 0.05 would be alpha for that 95% test. Standard deviation, this is our population standard deviation of 14, and our sample size of 47. Notice it does not ask for the sample mean because we're just getting the margin of error. The sample mean does not affect the margin of error. It affects the center of our confidence interval. So we get a margin of error there of 4.00246. So to create our confidence interval, we're simply going to have to take our point estimate of the sample mean, the 59, minus that margin of error, to that point estimate of 59, plus that margin of error. So we get about 55 to 63. It's 54.9975 to 63.0025. That is our confidence interval right there. Well, what if we're not given that population standard deviation? So this here was for population standard deviation given. What if the population standard deviation is not given? So let's take a peek here. So in this one, we take a sample of 39 items, and it gives a sample mean of, let's go 64, and sample standard deviation of 12. Keep our numbers simple here. Now you'll notice nowhere the very subtle difference here is in up here it actually says population standard deviation. Down here it says sample standard deviation. That's really the only little clues in the problem a lot of times that you're going to get to tell the difference. So we know this is we're going to construct here still we're going to go 90% confidence interval of the population mean. Okay, so now to find our margin of error, we're going to equals confidence dot t, and we're going to open up. So now we need alpha. This is a 90%, so alpha is 0.1. 1 minus 0.9 would be 0.1 or 10%. Our standard deviation, this is our sample standard deviation now of 12. And our sample size is 39. Again, it does not ask for the sample mean in any way. The sample mean is what we're going to use over here. So this is going to equal our sample mean of 64 minus the margin of error to our sample mean of 64 plus our margin of error. And there's our confidence interval for the sample, for the population mean, when we are not given that population standard deviation. So unfortunately, it's not so nice and neat for a proportion. If I want to do a confidence interval for a proportion, so let's say we have a sample of, let's do, usually for proportion, we do larger samples. Let's say a sample of 150 items gives 54 of them have, we're just going to say condition A. Find the, now let's do a 98% confidence interval for the population proportion. First of all, alpha is going to be 0.02 because it's the 1 minus the 98%. We need to find the mean, and the mean is going to be equal to n times p. So I guess before we can do the mean, we have to find p. And it's actually p hat because we're using an estimate from the population. That's going to equal the 54, which is the number that had that condition or that characteristic, divided by the 150 total. So we got a p of 0.36. So our mean is going to equal, well, the mean doesn't matter really. It's just going to be the 0.36 times the 150 would be 54. The standard deviation is more important here. And that's going to equal the square root of n, which is the 150, times p, which is the 0.36, times 1 minus p, So we get a standard deviation of 5.87878. So now in my confidence, I'm going to find my margin of error here. We're going to find my standard error here, sorry. Standard error I'm going to use here. Oh no, actually, let's plug this in. Okay, so when we're doing this, we see that, put this back in here, that standard deviation doesn't hold up. And the reason is because of the way the proportions are set up, we're dealing with percentages, not raw values. So what we have to do when we do our standard deviation, we're not really calculating a standard deviation. What we're doing is we're just finding the deviation in the proportion. So what we're doing there is just the square root of p times 1 minus p. So what we're putting in here, oops. So what we're doing is the standard deviation is the square root of p times 1 minus p. Is all that's going in there. So when we do that, then we find our margin of error. That is going to equal confidence. We put in our, I put dot norm, but it's going to default to norm if I don't put it in. Our alpha is 0.02. Standard deviation is the 0.48 that we found here. And our size is 150. That gives us 0.09117. So our confidence interval is going to equal the 0.36 minus that to the 0.36 plus that. And there is a confidence interval for the population proportion. So this is a little bit of work, and you have to remember that when you're doing your standard deviation, you're not doing the binomial standard deviation, it's just a proportion standard deviation. So it's per item is what you're getting. Oops. Undo that. Okay, so that is how we would do confidence intervals using Excel. If you have any questions, please let me know. Otherwise, have a great day.